Hello class, this is Math 1430, section 3.5. Here is our problem. Find the third derivative, because we're talking about higher derivatives in this section, meaning second, third, fourth, etc. Find the third derivative of f of t is equal to t cubed over 5 plus 1 over t plus 2. Also, find f triple prime of 1. That means at the third derivative, evaluate it for x, or t in this case, for t is equal to 1. So this notation means third derivative. Alrighty. First thing I want to notice here is that this expression, we do not need the quotient rule here. You could use the quotient rule. It's unnecessary though, because this is just a constant. So what I did first was rewrite. So for a solution, it's best to rewrite f of t first as this. So I took out the 1/5 and then multiplied it by the t cubed. And then I rewrote 1 over t as t to the negative 1. That way it's more derivative friendly, plus the 2. Now that I rewrote it, let us find the first derivative. So the first derivative, and what I did here was the power rule. I brought down the 3. The 3 multiplies the 1/5 for 3/5 t, and then you decrease the power by 1 to get the 3/5 t squared, and then minus t to the negative 2, because when you bring down the minus 1, plus times a minus 1 is a minus t, and then by the power rule of derivatives, you decrease the power by 1 to make that a negative 2. And then what's the derivative of any constant? 0. So our first derivative is just going to be that. You don't have to write the plus 0. You don't have to write plus 0. So there's my first derivative. So to go to the second derivative, you make sure you notate it correctly. So the first derivative is f prime. The second derivative is f double prime of our variable t. And here again, we use the power rule. You bring down the 2 to get 6/5 t. 2 decreased by 1 is 1. T to the first is just t. And then when I bring down this minus 2, I'll hold it. Okay, you might want to do it horizontally, I don't know. Okay, so my brother's holding the camera now. So f double prime of t is going to be 6/5 times t plus, because the minus 2 times a minus is a plus 2t. Don't write negative 1 here. That's a common mistake. What is this negative 2 minus 1? It's a negative 3. Okay, and that's it for the second derivative. Let's not rewrite this as 2 over t cubed, because then it's harder to take the derivative. Since I want to do a third derivative, leave it in this form, because this is derivative friendly. So the third derivative, which is denoted f triple prime of t, is going to be, well, the number in front of t is 6/5, so that's going to be the derivative of the first term, and then minus, because what's a minus 3 times the plus 2? You always multiply by the number in front. You get a minus 6t to the negative 4. Now that I'm done with the third derivative, let's simplify it as this. 6/5 minus 6 over t to the fourth. Now that we have our third derivative, let's evaluate it when t is 1, because that was part of our problem. So what is f triple prime of 1? You go to your simplified answer of f triple prime. Wherever you see a t, you write a 1. So I get 6/5 minus 6 over 1 to the fourth. Let's simplify that as 6/5 minus 6 over 1, because 1 to any power is 1. I need a common denominator when I subtract, so 5. So LCD of 5, which means I'm going to multiply by 5 over 5 for this term here to get 6/5 minus 30/5, which is equal to a negative 24/5. So let's just take a look at this whole problem so you can see it all. Let me just review it real fast. So find the third derivative of this function of t. Usually it's x, but it can be t, or y, or p, or r. It doesn't really matter. Okay, and then we also want to find the triple derivative, the third derivative evaluated at t equals 1. So before we do anything, we rewrite the function to make it more derivative friendly. So to avoid the quotient rule, I pulled out the 1/5 times t cubed. And then we wrote 1 over t as t to the negative 1, because t is like t to the first. T to the first on the bottom goes up as t to the negative 1. And then I rewrote the plus 2. It's still the function f. That's why I did not write a prime here. It's still f of t. Now we're ready for the derivative. So the first derivative is denoted f prime of t, and we got this answer. And then we took the derivative of this derivative to give me the second derivative of this. And then the derivative of the second derivative is the third derivative, which is this. And then I simplified it because we just had to stop at the third derivative. And then we evaluate it for t equals 1, and we are done.